Good evening, everyone. Welcome to the homework portal. Once again, we are into looking for the structured problems. So far, I think in mechanics chapter for IBDP, DP2 examination point of view, I had already given you a few MCQs, okay, as a part of revision. And now what I'm going to do is we are going to do something on structured problems. And one way of doing it is like taking up a past paper and then solving several problems out of it in line. That's one way of doing it. The other way of doing what I prefer is that since the concepts has been taught to you clearly and you had been mastering the, just a moment, something wrong. I'm not able to get it correctly. Yeah. So one way of looking at it is by looking at the past papers. The second method, which I prefer, is that since you have already learned the concepts and you also learned or you also practiced the MCQs, okay, in paper one for the first chapter, that is mechanics. I felt maybe we can now focus more onto the second paper, which is structure paper. So towards this, there will not be 5 questions. There will be at least 3 questions from the structured paper taken from past papers or from textbooks. I would like to introduce here. So today, in a similar pattern like what we had done for MCQs, we'll be continuing with the same way. So today we will be working on that is, I'll be showing you the questions. And tomorrow what you need to do is by 3:30 or maybe, no, maybe by 1 p.m. Okay, I think I will be rolling over or I'll be giving you the solutions. Okay, so this is what I'm going to do it. Your MCQ questions are until 27th, I think, right? Until 27th. So I think then it's better that I will start from 27th itself. Anyway, I will just record all those and put it across. Today is 25th Christmas. I'm totally free at home. So I thought, okay, why not we do this one and put it across? Fine. So I'll do one thing then by 20. This will start for you from 27th onwards, where the MCQ is already getting over and you will be just having the structured type questions, which would be acting as a homework for you for every day. So you can try it out, and we will also try the same thing in the classroom also, which would really be helpful for those who are revising mechanics. Okay, so with this brief introduction, let me start with the questions. So today I am just sharing with you the questions over here, and tomorrow the answers would also be displayed. In the meantime, you have 24 hours. Try it out. Do not look for answers initially, but instead try it out, solve it, and later on look for answers. And please do let me know which questions, okay, you were not able to fare properly and what were the misconceptions you observed. Those concepts, I will take it separately and put it in the misconceptions. I'll identify what kind of errors did you do it, and then we'll put it across. So far, misconceptions in physics has been worked out only for the JEE mains problems or NEET problems. I had not looked much into the IBDP or IGCSE problems. So currently, with your help, the only thing that I expect from you is that I would like to know what made you commit that particular mistake, and hence I can recognize it, and it will be helpful for me to look at why did you do that mistake and how do you overcome it, or where you had to apply a particular concept, in which contextual situation you would like to apply it. So this is where misconceptions in physics comes into play. So I need your help towards it. So you can write back to me letting me know what kind of mistakes have you done. Okay, now let us begin with the problem. Right, just a moment. Let's just give me a moment. I'm just taking that across. Right. Okay, so this is my new template. The old template was only for MCQs. Now this is how it looks like. So every day, 3 problems would be posted. I know 3 problems will take at least half an hour for you to work it out. Okay, but exams are coming nearby, so you need to spend so much time. Okay, let me proceed further. The first question says a company designs a spring system for loading ice blocks onto a truck. You are loading ice blocks. From here, the ice block is placed in a holder H. Holder H in front of the spring, and an electric motor compresses the spring by pushing H to the left. You are not pushing it, but there is a spring and there is a motor which compresses the spring. And then by pushing H to the left, and then when the spring is released, the ice block is accelerated towards the ramp ABC. The moment you release the spring, what happens? There's a potential energy stored in the spring, and this potential energy renders the ice block to move further. When the and accelerate towards the spring or ramp ABC, when the spring is fully decompressed, which means what? It becomes, now you are compressing it. It becomes completely decompressed. The ice block loses contact, which means until it decompresses, the ice block and the spring are in contact. So as a result of it, the moment it becomes completely decompressed, it comes over here and joins at point E, or it lands into point A. And with the contact with spring at A, the mass of the ice block is 55 kgs. Mass of this is 55 kgs. Assume that the surface of the ramp is frictionless, and the masses of the spring and the holder are negligible compared to the mass of the ice block. Surface of the ramp is frictionless. So this is my ramp over here. He has not spoken anything about the region AB. Okay, the block arrives at C with a speed of 0.9 meter per second. It arrives at a speed of 0.9 meter per second. Show that the elastic energy stored in the spring is 670 joules. So what is the elastic energy? That you need to find out. If the speed here is 0.9, then you can determine what could be the speed here, what could be the speed over here. Okay, and as a result of it, you can get it here. Note that this distance is not given to you. So now you need to use your common sense to understand how to solve this problem. Okay, now this is the first thing. So if you know, your first thing is the value of K is not given to you, right? Elastic potential energy stored in the spring. Okay, so therefore K is not known to you. Half Kx square is your energy. X is also not known to you. How much it is getting compressed, that's also not given to you. Wow, see how complex it is, right? It's not complex, but you need to know how to solve it. But the only thing that is given to you is the speed at this point is given to you. And at the same time, look at this 1.2 meter, which means the object, the ice has been able to go against the gravity. So okay, that's also been given to you. Now I hope you know about what do I mean. Somewhere when I say against the gravity, what does it tell you? It tells you work has been done against gravity. So which means, once again, it is the mgh which comes into. Okay, but there's something else also apart from it, but I'm not going to reveal everything. Think about it. Right, then calculate the speed of the block at A. What is the speed of the block at A? What will be the velocity here? At the moment it leaves it. That also you need to know. Right, let us move on to the next one. So in the same question, okay, I'll do one thing. Let me just remove my video because, video might be blocking the diagram, and the diagram is very essential to understand the problem. Right. Describe the motion of the block. Describe the motion of the block from A to B with reference to Newton's first law. Somewhere this is giving you a clue. Okay, from A to B, what is the Newton's first law? Apply Newton's first law to understand the motion. Right. From B to C with reference to Newton's second law. Now here, okay, though he says this region is frictionless, now understand what is going on here with respect to Newton's second law. So which means somewhere you need to bring in the acceleration part, right? So here also some acceleration, here also some acceleration, something like this you need to describe it. Okay, now let us move on further. On the axis, sketch a graph to show how the displacement of the block varies with time from A to C. You need to plot a graph of displacement versus time. Now, what is the displacement? Displacement would be starting from A to C over here. So how does it vary, right? When it is going from here to here, now how does the displacement change? And from B to C, how does the displacement change? And when we say displacement changing, there's something which you need to put across. What is it? The slope of the displacement gives you velocity. So somewhere you need to focus more on the velocity here and velocity here, right? Think about whether the velocity can be same or can be different, and then plot it accordingly. Okay. So I hope I have given all the clues. It's just like teaching you how to solve a problem. But only thing is you need to know how to solve a problem now. Right. Just give me a moment. Uh, Just a moment. I will be back. There is some urgent message that I need to send across. So that's the reason I just stopped for a while. Okay, I think I am back here. Okay, let me put on my video also. I changed something. Okay, now we have done this problem. Now let us do this problem. The spring decompression takes 0.42 seconds. Determine the average force the spring exerts on the block. Force. What do you mean by force? Change in velocity divided by time taken multiplied by mass, right? Is the mass of the ice block given? Given. Then what about change in velocity? Change in velocity, you should find out the spring compression, decompression takes place 0.42 seconds from a highly compressed position to a relaxed state. It takes 0.42 seconds. You need to decide. The time is given now. Now you need to find out what is the average force. What is the average force? Average force is nothing but change in momentum divided by time taken. So you can determine this, right? So I need not tell you how to determine it. The answer to this starts or begin or initiates from the answer that you got from here. Where is it? From here. Calculate the speed of the block at A. If you know what is the speed of the block at A, and you know this is the place where it is completely decompressed, right? And you also know what is the speed when it was completely compressed, right? So therefore, now you should be able to solve this. Right, let me move on next. Next is, where is it? Right, here. Okay, now the electric motor is connected to a source of potential difference 120 volt. Now, as we had said already, the spring doesn't just directly decompress or compress. If you want to compress, you need to apply some power on it, some force on it, right? So therefore, you have applied a potential difference of 120 volts and a current of 6.8 amps, and the motor takes 1.5 seconds to compress the spring. What is given here? Potential difference is given, current is given, time is given. V, I, and T. Okay, I have just given you an acronym. Think about it. What does VIT gives you? VIT doesn't stand for Vellore Institute of Technology, right? It tells you something else in physics. So think about it. And from here, estimate the efficiency of the motor, right? So he is asking you about the efficiency of the motor, which you can easily do it. So efficiency is given by the formula output by input, right? You can try it out and you can get the answer for this. Right. Next, on a particular day, the ice blocks experience a frictional force. Particular day, ice blocks experience friction force because the section of the ramp from A to B is not cleaned properly. This is not cleaned properly, which means what? Earlier it was cleaned properly, right? I think this gives you an answer for the previous problem, the first part of it. Okay. So the coefficient of dynamic friction between the ice blocks and the ramp AB is 0.303 and the length of AB is 2 meters. Determine whether the ice blocks would be able to reach C. One speciality in IB problem is that, okay, so usually it will be like the first question, there will be a question and then you need to work out one part of the problem. The answer that you get for the first part might become, okay, the input for the second question. And thus it proceeds in a zigzag way like this. This one approach which most of them do it. The second approach is that read the complete question once. Okay, see there are F until how many? Around 5 to 6 parts over here. So when you come to this fifth part, we are getting a clue here. Somewhere the clues are very much hidden. Okay, so therefore, so you need to read this. Now, what is given here? Friction is given, length is given. Determine whether the ice blocks will be able to reach the point C. Why does he say that? Because what happens is when the decompression takes place and the ice lands onto it, if there is no friction, definitely object will be able to land here. When there is a friction, some amount of energy is now given back to it. Now, when it is being given back, it may be able to climb only until here. It may not be able to climb for the whole part. If it is not able to climb until the end, then what will happen? The object or the ice will not be able to reach the point C. This is what he makes. Okay. So we have logically reasoned everything. You need to start working out on it. Right. Next. Second question. A tennis ball is hit with a racket from a point 1.5 meters above the floor. Now you see this is a projectile motion here. Okay, you are hitting the racket with 1.5 meter per second at an angle of 50 degree and the person's height is 1.5 meters. And then the ceiling is at a distance of 8 meters. Right, the velocity, initial velocity is given, assuming that the air resistance is negligible. Determine whether the ball will hit the ceiling. When you hit it across, is it that the ball will straight away go like this and hit it, or it will just go like this and fall over it to the other edge. Now, how do we do it? So what do you mean by hitting it? Which means the maximum height. With all the available or given parameters, would you be able to calculate the maximum height? And if you are able to calculate, then find out using that and some reasoning methodology, determine whether the height, whether the racket, whether the ball will hit the ceiling or not. Then the tennis ball was stationary before being hit. Of course, everybody will have it in hand. If it has a mass of 5.8 into 10 power minus 2 kgs, so the mass of it is given and was in contact with the racket for 23 milliseconds. Oh, it mentions that, okay, the moment you start hitting it like this, so then what can happen is, or maybe you hit it like this, then there is a possibility that it was in rest, okay, with the bat for 23 milliseconds. Calculate the mean force exerted by the racket on the ball. Think about it. Wonderful problem. Okay. So we'll see this. Okay. Definitely. I know some of you might be thinking you might put mg divided by time and so on. It is not mg because mg is the downward force. But we are talking about what is the force exerted by the racket on the ball. Okay. Think about it carefully and then answer it. Right. Explain how Newton's third law applies when the racket hits the tennis ball. So how does it apply? So you need to think about it. Okay, so what is Newton's third law? Action and reaction are equal and opposite. So you need to know which one is action, which one is reaction. And then you will be able to reason it appropriately. Then, curling is a game played on a horizontal ice surface. Okay, the new game is describing. A player pushes a large, third problem, large smooth stone across the ice for several seconds and then releases it. So he is going to throw his, sorry, a player pushes a large smooth stone across ice for several seconds. See, remember, he doesn't say anything that the stone ice was pushed across an inclined plane. Okay, he says it is being played on a horizontal ice surface. Do not mistake this graph with the play. This graph only tells you the variation of speed with time. Okay, it has nothing to do with the pushing methodology. The stone moves until friction brings it to rest, which means what? Now initially he is throwing, initially when he is pushing, see, a player pushes a large stone. That means he's constantly pushing it, which means what? The velocity or speed is increasing with time. Okay, and then releases it. When he releases it, what should happen? When there is no external force, okay, the block should be continuously moving forward with the same constant velocity. That means you should expect a horizontal force here, horizontal line here. But the moment he leaves his fingers, now you see, it comes down. Why does it come down? That means speed is decreasing. The graph shows until friction brings it to rest. The moment you leave your hand, there is a friction, and as a result of this, okay, the block actually comes to rest. Total distance traveled by the stone is 17.5 seconds. In 17.5 seconds is 29.8 meters. Total distance is given to you. How do you find distance from speed time graph? Area. Okay. Determine the maximum speed v of the stone. You should find out what is this value of v. I'm not going to tell you the method. I think I have already expressed, okay, what you need to do. Think about it. Determine the coefficient of dynamic friction between the stone and the ice during the last 14 seconds of the stone's motion. Between here to here, what was the value of mu? You need to determine it, right? So how do you do it? It's left to you. Okay, I'm not going to say anything about it. Think about it and then do it. The diagram shows the stone during its motion after release, right? This is a stone after release. Label the diagram and show the forces. This is nothing but your free body diagram. It has nothing to do with this free body diagram. Of course, you have something, okay? I should include the name, direction, and the point of application of each force. Which forces are acting, you should mention about it. So, okay, so then that's it. Fine, so we have seen 3 problems. Definitely it has taken, for me, it has taken around 10 to 12 minutes. And thank you, friends, for watching this video until the end. And if you really like it, do share with your friends and subscribe to my channel for more updates. Definitely every day I'm planning to give you three problems. You know, you're not working for me. You are working for yourself. And if you do all these questions appropriately, correctly, then definitely you have an edge. You can easily score a 7 in your main exams. And if you don't, I can't help, right? So definitely, you know, what had happened these days is not important. You need to look at how you will get through all these problems. If you have been consistently getting a 2 or a 3 or a 1, doesn't matter. Try out with this methodology. You will be able to score 7. I can tell you very clearly. Okay. But never falter around it. To answer these problems, 3 problems per day, you might require half an hour strictly. And of this half an hour, 3 problems, you might be able to do only something like a few problems, not everything. But don't give it up. Try it to maximum extent. Tomorrow, when the answers are being posted, have a look at the answers. Very, very important. Have a look at the answers and see where you have made a mistake and do write back to me. Maybe you can put in the comment sections like where that mistake happened and why did that happen. What was your assumption and why did you get it? Okay. So if you do this correctly, then definitely you would be able to score a better mark in your examinations. Anyway, too much talking. Thank you. Thank you, friends, for watching this video until the end. And see you once again tomorrow evening. And do share and subscribe to my channel for more updates. Thank you.